This program. On line 1, we have a console.log statement, which is logging this information that says 1.start. On line 3, we have this scheduler function, which is a set timeout. Inside our callback function, we have a console.log statement that says 2.inside timeout, the macro task. And then our delay period is 0 millisecond. Now, on line 5, we have a promise dot resolve. So when this promise resolve, it takes a dot then method and then a callback. It says a console.log3.promise resolve, a micro task. On line 7, we have a for loop. It doesn't do anything at the minute. And then on line 11, there is another console.log statement that says 5.end. Now, we want to look at the order of execution of this program. So let's go to our browser and check what we have in our console. Now, you see in our console, we have start, which is the first line, is executed. And then we have 5.end, which is the last line, line 11 here, being executed second. And then followed by promise. And then the inside timeout, which is our set timeout scheduler function. Now you look at the order of execution. It starts from here, 1, you see? And then we don't see anything here, but then we see the result here, right? Now if I uncomment this and then I save it, let's see what we have. Let me refresh this. Okay, so you see it blocks, this line 4 blocks the last line. Okay, but then so we have line 1, this one, and then line 7, 8, 9, or whatever you call this, it gets executed. This for loop program gets executed, followed by this, then followed by this, as you can see here. So the 1000 loop completes, and then we get 4 loop completes. The last program here is executed, and then we have promise resolve inside timeout. Now, what is happening here? Now, JavaScript is single-threaded. What this means is JavaScript has one call stack and can only execute one piece of program, that is one line of code at a time. Now, in modern JavaScript environments like the browser or Node.js, this environment provides us tools to achieve concurrent and parallel execution. So what is happening here is, you see, this program is being executed in a browser. So the browser is a runtime environment for this program. Now, because JavaScript is single-threaded, it has one call stack. Now, the synchronous programs, they get executed first. So the first line, this console.log, is synchronous. It gets executed. So remember, it has one call stack from top down, one line at a time. So the synchronous the synchronous code, they get executed first. Now, whenever JavaScript encounters asynchronous programs, like set timeout, like promise, async, we're going to get into all of that later on. What JavaScript does is it pushes these programs to the background, away from the main thread, the main synchronous thread. It pushes these two codes to the background, to the web APIs. And then the synchronous programs get executed first. When the synchronous programs, when they're done executing, there is a mechanism known as event loop. These mechanisms allow, this event loop is the core mechanism that allows us to perform asynchronous operations without the complexity of multi-threaded programming. So after the synchronous operations have completed, the event loop, which has like a traffic controller anyway, which is continuously monitoring, what is it called? It's continuously monitoring the call stack and the task queue. So what JavaScript does, it pushes this asynchronous programs in the background into the task queue. So when the call stack is empty, the event loop, it checks the task queue to check for the next task that has the highest, how do I call it now? That has the highest order of execution, and then it pushes that to the main stack or the call stack to be executed. Now, when you look at this set timeouts, or before I get into this, let me show you this infographic. See, JavaScript event loop. I'm going to zoom this in so that you can see what is happening. Now you look at the first picture. This is the big picture. It says JavaScript offloads tasks to the environment. When those tasks complete, their callbacks are queued and executed. All right, so we have the event loop here. Remember, we said the event loop is the core mechanism that allows us to perform asynchronous operations without the complexity of multi-threaded programming. Now, so we have the call stack, which is one thread. So all of these function here, blah, 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 blah. Okay, fine. And then we have micro task queue, high priority, macro task queue, low priority, and then web APIs. So whenever, you see these web APIs, the browser, Node.js, we said when JavaScript encounters asynchronous operations, what it does is it pushes them to the web APIs. So you see all this set timeout, fetch operation, like we're trying to fetch something from the network, DOM event, file, input, output, things like this. JavaScript push those code to the web APIs. Okay. Now it executes the code on the call stack here. LIFO, lasting first out, using that approach. Okay, so function A, function B, function C, like that gets executed. Now, after the event loop checks whether the call stack is empty. Now, when the call stack is empty, the event loop, it goes to the task queue. In the task queue, we have macro task queue. We have macro task queue. Macro task queue. The micro task queue, the code in this micro task queue, they have high priority. So code that has promise.then or queue micro task, mutation observer, things like that. These have higher priority compared to code in the micro task queue, like set timeout, set interval, input output callbacks, UI event, things like that. So after the call stack is empty, that is the main thread, when it's empty, the event loops goes into the micro task queue, get the task, the next task there, it pushes it into the call stack, and then it's executed. All the programs occupying the macro task queue or the tasks there have to be executed first before the event loop goes into the macro task queue to fetch the next task here. So that's why here you realize that, okay, these are the synchronous operations. Line 1, line 7 to 9, line 11, those executed first. Now, these, line 3, line 5, these are the asynchronous programs. Promise.resolve, this, it has higher priority than the set timeout. So this get executed next after the synchronous operations have completed. So you see, 1, the loop, the last one, and then promise, which is the micro task queue. Then after that, the set timeout get executed. Now, when you look at the set timeout, you look at the delay period is 0. You might think, well, delay period is 0. Why is this executed last? So it turns out that this delay period is not a guaranteed execution time. Rather, it's the minimum wait time. So even if you are set this to 1000 milliseconds or whatever, once it counts down to 0, it's going to wait inside the task queue until the call stack, that is the main thread, is empty, and then the event loop will now push it into the main stack to be executed. But you realize there is another micro task here. This has higher priority than this. So the promise get executed first before the set timeout is executed. So whenever JavaScript comes across asynchronous operations, it pushes those code into the background to the web APIs. So whether it's the browser environment or Node.js, it just pushes it into the background. And then it executes the synchronous operations first. When the call stack, which is the main thread, when it is empty, the event loop, it goes into the task queue to fetch the task that has the highest priority in them, pushes it into the call stack, that is the main thread, to be executed. So you have example of execution. Okay, I think we've done this. We've done this. So how the event loop works, it runs the code in the call stack. When async operations are called, they are sent to the web APIs. When an async operation completes, its callback is added to a queue. Okay. Now, if the call stack is empty, the event loop checks the microtask queue first. It executes all microtasks, that is first in, first out, until the microtask queue is empty. So all the codes in the microtask have to be executed first. And then it takes the first macro task from the macro task queue and executes it. And then this process repeats forever. So guys, this is how event loop in JavaScript works. So the key takeaways is JavaScript is a single threaded but asynchronous. The event loop is the secret behind concurrency. Microtags greater than macrotags. Microtags always run first. Keep callbacks short. So we're going to get into this later and understand the other helps avoid bugs and write predictable code, things like that. All right, so guys, I'll see you in the next video.